Okay, class, let's start. Okay, so first question. Okay, prove that sine 3 theta is equals to 3 sine theta minus 4 sine cube theta. So for this one, how do we start is we'll have to use the compound angle formula. So we'll have to use the sine A plus B first. So how do we actually get the A plus B is that we start with the A is 2 theta and then the B is a theta. Okay, because we know that the 3 theta can be split into 2 theta and theta. Okay, so from there we apply the compound angle formula. So if we have sine A plus B, okay, it actually gives us sine A cos B plus cos A sine B. Okay, so from what we have there, we have sine 2 theta. So sine 2 theta, we have to apply the double angle again. So the double angle gives us 2 sine theta cos theta. And in another term, we will actually have a cos 2 theta from there. So for the cos 2 theta, we can actually use 1 minus 2 sine theta. Okay, so again, this is the double angle. Okay, so after that, okay, what we have to do is we expand, okay, the terms. And once we expand the term, we still have something which is in terms of cos, okay, where we still have the cos square. So for the cos square, we just have to use 1 minus sine square to replace it. And then just have to rearrange it nicely and tidy up, then we will get the result for the sine 3 theta, okay, as what we have to prove. So of course, the next part of the question is asked us to prove that sine theta plus sine 3 theta is equal to that expression. So for that, okay, because we have proven for the sine 3 theta, so we just have to add another sine theta to the sine 3 theta. Okay, so this is what we add to the expression for the sine 3 theta. So from there, okay, we will actually have 4 sine theta after we add up the sine theta term. So from there, we factorize out. Okay, we factorize out the 4 sine theta. Then again, we will actually have something which is 1 minus sine squared theta. So 1 minus sine squared theta can be written as a cos squared theta. Okay, so this is why we can actually get that result from there straight away. Alright, so for the next part is to find the values of the theta, okay, such that theta, which is from 0 to 180, okay, it satisfies this equation. So we can see that the right hand side is something that we have proven earlier on. So most of the time is we actually use the result that we have proved earlier. Okay, so if we apply the result that we have proved earlier, it is easier for us to solve this. So from the result earlier, okay, this is what we have for the right hand side. And for the left hand side, we have got a cos squared over sine squared. So for the cos squared over sine squared, we have to move up the sine squared, okay, then we get sine power 3, okay. And then for this case, we will see that we actually have cos squared for both sides. Okay, so in this case, always remember we do not cancel off, okay, because we will lose some of the solution if we actually cancel off. So what we do is we move the cos square to the right hand side, and then from there we factorize out the cos square. So we actually have two parts of the solution. So the first part of the solution will be cos squared theta is equal to 0, which gives us theta is equal to 90. And for another one, we have the sine theta is equals to the cube root of 1 over 4. Okay, so from there we find out what is the basic angle. The basic angle is 39.0, and because this is sine, and then for this sine it has the positive value. So for this one we have two quadrants, which is quadrant 1 and quadrant 2. So other than the quadrant 1, okay, which is just the basic angle that we have found, we also have quadrant 2. So quadrant 2 is used 180 to minus the basic angle. So from there we actually get two values for the theta. Okay, so in the papers, remember when we actually give the answer for the data, according to the instruction that we have in the cover page, we should give the value for the degree, okay, to 1 decimal place, okay, unless they need like other accuracy. Okay, so this is what we have for the first question. The second question that we have from there is we need to first, okay, sketch the graph of 2 secant x and 1 plus 3 cos x. So I guess for the graph which is 1 plus 3 cos x, it is not difficult to sketch. So if you look at the graph separately, so what we have is we have, so this x is from 0 to pi. Okay, and then we also have pi over 2. So what happens for the 1 plus 3 cos x is that we can first sketch what is 3 cos x. So 3 cos x will take the value, okay, from 3 to negative 3. Okay, so this is for the 3 cos x. So what does it mean by 1 plus 3 cos x is that we just have to move the whole graph, okay, up by 1 unit. So when we actually move the whole graph up by 1 unit, so we will actually have something like this. So the values now will become 4 and negative 2. Okay, so this will be the values for the 1 plus 3 cos x. And this is for the, of course, 1 plus 3 cos x. So how do we actually deal with the 2 secant x is that? Okay, so what we need to know is we just need to know what is the shape for the cos. So we will actually have to see what is the cos x graph. Okay, so we do not need to really memorize the graph for secant or cosecant, as long as we know the property for the cos and sine. Okay, so what happened to this one is that, okay, so again this is our cos x graph. So we will have pi and pi over 2. So the two values here are 1 and negative 1. So this is for our cos x. Okay, so imagine now, okay, we want to find the value for 1 over cos x, which is a secant. Okay, let me use another color. So y is equals to secant x. So in this case, it's a 1 over cos x. Okay, so for this 1 over cos x is basically we 1 over those values that we have along the curve, okay, that we already sketched in the cos graph. So there are actually two obvious values. So this is a 1. So when cos x is equals to 1, 1 over cos x, which is secant x, is also equals to 1. Okay, so we know that there is a value for the cos x in when we have the y is equals to 1. So the same case, it happens, okay, when we have y is equals to negative 1. So when cos x is equals to negative 1, secant x, okay, which is 1 over cos x is also equals to negative 1. So we actually have a value here. Okay, so what about like the other values that we have for 1 over cos x? So for 1 over cos x is, you see like for this one, for cos x it is decreasing. Okay, so when we actually 1 over those values, okay, we will actually have the values which is increasing. Okay, they will have the opposite behavior. And at the same time, what we have is that when our x is pi over 2, the y is equal to 0. So when we actually try to find the curve for the secant x, which is 1 over cos, then we will actually end up with 1 over 0, which is undefined. So in that case, we will actually have an asymptote which is like this. Okay, so what we have for this curve would be, this one is increasing. Okay, so same case when we have the x from pi over 2 to pi. So originally for cos x it is decreasing. So when we have 1 over cos x, the graph will actually increases. Okay, so this is a part of the curve that we will actually have for the secant x. Okay, so now what happens is we have got 2 secant x. So 2 secant x means we will actually have, in this case, the value for -1 and 1, it will become -2 and 2 because the values are double. So this is why we will see that for the graph for the secant x, okay, we will have the starting point of 2, and then at that point here is a -2. Okay, so this one will be the secant x graph. Okay, for this one will be the y is equals to 1 plus 3 cos x. Okay, so these are the two graphs. So just have to take note that the two graphs, okay, we actually have two intersections. So one is here, which is quite obvious. And for the second one, just remember that they will actually end at the same point. Okay, so this is what we have. So they will actually end at the same point here, because you see for the 1 plus 3 cos x, okay, it ends at y is equals to -2. At the same time, when we actually try to sketch for the 2 secant x, so secant x is -1. So when we have 2 secant x, this point will be -2. So they will actually end up with the same point. So we actually have two solutions from there, okay, for this curve. So next one, okay, what happened for the next one is that we have got to solve this equation. Okay, so when we actually have this equation, it means we are looking at the intersection point for both curves. So when we actually look at the intersection point for both curves, okay, what we have would be just move up the secant, okay, to the right hand side. So we actually have a cos x plus 3 cos square x in our right hand side, and this is nothing but quadratic equation. So basically from there we just have to solve this quadratic equation. Okay, so solving the quadratic equation is not difficult. In fact, we have got 2 points, okay, intersection point. So one would be x is equals to pi. So make sure we get that, because we have already shown it in the diagram already. We know it is going to be pi for the value of the x for the intersection. So another value would be 0.841. Okay, so this can be also easily verified and see that, okay, this point must be some point which is in between 0 to half pi. Okay, so for this value, actually, it is actually a value which is in between 0 to half pi. Okay, so the curve is actually help us to actually make sure that our solutions are correct. Okay, so that would be for the second question. Okay, for the third question, okay, is to first part is to prove that we have got sine squared 2 theta times cot squared theta minus tangent squared theta is equals to 4 cos power 4 minus sine power 4. Okay, so for this one, okay, how do we start is just look at the angles. So we have got 2 theta here. Okay, we just have to use the double angle to express it into everything in terms of theta. Okay, so how do we start is by first, okay, using the sine 2 theta is equals to 2 sine theta cos theta. In this case, we are squaring the whole thing. Okay, the whole thing must be squared. So we have got a 4 there. Okay, so we have 4 and we have sine squared and cos squared. So for this 4 sine squared cos squared, we just have to multiply in to the bracket. So for the cot and the tangent, okay, we can write that as a cos over sine. And also we have sine over cos squared. So basically just have to multiply in and cancel off the terms. So from there we actually have what we need to prove. Okay, so this one should be quite okay. Next part is to show that the right hand side, okay, is just 4 cos 2 theta. So how do we prove this is so earlier on, okay, what we have proven is that, okay, we have got cos power 4 minus sine power 4. So for this one, okay, it is a form that can be factorized, where if we have a squared minus b squared, so in this case it's a plus b, a minus b. So what are our a and b here? The a here is a cos squared theta, and in this case the b here is a sine squared theta. Okay, so that would be the how do we actually factorize this? So once we factorize this already, we will actually get one term, which is a cos squared theta plus sine squared theta. So this one is very familiar. It is equals to 1. And for cos squared minus sine squared, it is just our double angle. So that would be our cos 2 theta. Okay, so this is how we prove for the first part. The second part is then, okay, we have to solve the equation. Okay, so for this equation, the whole left hand side here is equal to this whole left hand side. So of course we can just apply, okay, our result to solve this equation. So what we have is at last, okay, what we have is we actually have 4 cos 2 theta is equals to 2, which gives us the cos 2 theta is equals to half. So remember, whenever we solve the angle, okay, here, which is not just a theta, we have to always change the range, okay. So for this one, given that we have got the theta at 0 to 360, so 2 theta must be from 0 to 720. Okay, so of course, how do we deal with this kind of the situation is that we just give our answer as if we are solving for 0 to 360 first, and then we will see whether we need to adjust from there or not. Okay, so this is done, okay, by finding the basic angle first. So for this one, cos 2 theta equals to half gives us a basic angle which is 60. Okay, so from the 60, we know that this is a cos positive value, so we have quadrant 1 and quadrant 4. So just give the values from the quadrant 1 and quadrant 4. Okay, so we will get 60 and 300. So from there, we will see like whether do we need to add 360 to the angles or minus 360 to the angles to get all the angles that we need in the range for the 2 theta. So for this case, we need to actually add the angles, which is 360. Okay, to both, okay, 60 and 300 to get another 2 values from there. Okay, so we have 420 and 660. So from there, we are not going to add 360 again because it will actually out of the range already. So these 4 values would be our answer. Okay, so with that, how do we find the theta is we just have to divide by 2, okay, for all the values. Then this would be the complete set of the values that we will get for this equation. Alright, so that would be for the part 2. Okay, for next one, it's quite a standard question, so I won't actually really go through. I'll just go through that very briefly. So it's to express in this kind of the form. So this kind of form, we call it as a harmonic form. Okay, so basically is to expand this harmonic form by using the compound angle formula. So this one we have like sine theta plus alpha. So basically just expand it by using the compound angle formula. Okay, so this is what we get for the compound angle formula. And from there, okay, we just have to compare with what is given earlier. So we have sine theta and root 3 cos theta. So just have to compare sine with sine and cos with cos for the theta. Okay, so if we actually compare the first one, we have got, if we compare the sine theta, we have got r cos alpha would be the coefficient for the sine, which is a 1. Okay, which we get the second equation from here. Another term is if we compare the cos theta, we will actually have r and sine alpha is equals to the root 3. Okay, so with that we can actually have 2 equations. Okay, so how do we actually get the r is that we just have to square both the constants that we get, which is root 3 and 1. We square them, add them together and take the square root, we will actually get the r is equals to 2. As for the angle for the alpha, okay, I will recommend by using the 2 values, okay, to actually divide. Okay, we have 2 equations there, so we divide. So we use first to divide by the second to give us a tangent. So tangent, we will actually have pi over 3. So tangent alpha equals to pi over 3 actually gives us a nice value, okay, which is alpha is equals to pi over 3 for this one. Okay, so that's for the first part. For the second part is to solve this equation. Okay, so in order for us to solve this equation, we'll actually use the result that we have earlier on. Okay, so for the result that we have earlier on, we actually end up with this. Okay, sine theta plus pi over 3 is equals to 0.4. So just be a little bit more careful when we actually try to solve this equation, because this is not just theta alone. So basically this is theta plus pi over 3. So we have to first adjust, okay, the range, okay, for this theta plus pi over 3. So first thing is to obtain the basic angle, which is 0.411. So from there, okay, what we actually have is we have to see whether this 0.411 is in the range or not. So in fact, for this 0.411, it is a value which is out of this range, okay, pi over 3 to 4 pi over 3. So we are going to take the next value, because this case we have got sine is a positive value and 0.411 is an angle in the first quadrant. So to get the second quadrant, we use the pi to minus this 0.411. Okay, so that will be our first value. So from there on, okay, we just have to try to see whether we need to include more values from there. Okay, so in this case, what we have is we actually have, if we will want to include the following values, okay, for the next cycle. So for next value, okay, because originally we have 0.411, right, in the first quadrant. So when we actually want to get the next value is we have got 2 pi to plus with the 0.411. So in this case, it is quite obvious that it is out of the range already. So from there onward, we are not going to consider that. Okay, so for this one, we only have a single value for the theta. Okay, which in this case, when we actually find the value for the theta is 1.68. Okay, so they need the angle to be rounded to 3SF. Alright, next one. So use the identity of tangent 2x to show the identity for tangent 4x. So for this one is to use the double angle formula for the tangent 2x. Okay, so how do we start is we start with the tangent 4x because it is given earlier on the value for the tangent 2x. Okay, we can use the identity. So when we actually use the identity from there, it is about changing, okay, because this is 4x, right? So now in our identity it becomes 2x and a 2x here. Okay, so this is where we end up. So we actually have like tangent 2x in our expression. So the next thing is we just have to substitute again what is our tangent 2x, which is in terms of x. So you can see there are two big brackets here. Okay, we just substitute that in, and the next thing is just try to simplify, okay, by using your method. Okay, so by using any method that you actually try to simplify is we should be able to get the result, okay, that we want to prove. Okay, so I guess you have your own way in simplifying lah. So we should be able to get the results, okay, as long as we work with the expressions very carefully. Okay, so that would be the first part. Okay, so as for the second part, okay, what we have in the question it's about, okay, they say heads. So given that x equals to 1 over 6 pi, it is a root of the equation tangent power 4x and so on, okay, where p is a positive constant, so find the value of the p. Okay, so for this one is we are trying to relate this equation, which is like in terms of power of 4, with the identity that we have proven earlier on. Okay, so how does it work? So of course the first part is to prove, okay, x equals to 1 over 6 pi is a root of this equation. Okay, so what happens is that if, okay, we let the x to be 1 over 6 pi, so what happened when we actually try to substitute that, okay, into the left hand side of the identity? So what is our left hand side of the identity? The left hand side of our identity is tangent 4x. Okay, so if we actually substitute this into our left hand side, so our left hand side will actually give us a value for, which is tangent 1 over 4 pi. So tangent 1 over 4 pi is a 1. Okay, so if we have this value of the x, okay, the whole thing that we have for the right hand side, it should be equals to 1. Okay, so because in this case the left hand side, which is tangent 4x, is equals to the right hand side, which is a bunch of the expression which involves the tangent x. So it means when we substitute the x, okay, into the left hand side, which we get a 1. So if we were, okay, to substitute this x into the right hand side, we should get the 1 as well. So this is what they mean by the x is a root of that equation. So we need to prove that the equation, okay, that we have in the question actually comes from the identity. Okay, so for that one, okay, we substitute the x equals to 1 over 16 pi into the tangent 4x already, we get a 1. So from that, from the 1, okay, we just have to expand everything. So just move up the denominator, okay, and from there we just have to rearrange it. So with that we can actually get exactly the same equation that is given in the question. Alright, so from there, okay, we just have to compare the value of the p, okay, with the question. So in that case, the p is a 4. Okay, so this is to relate the value for the x with the equation that comes from the identity that we have proven. Alright, so that would be the solution for this question. Okay, next one. So for this one is given that angle theta is acute when we have the cos theta is equal to 3/4. So without using a calculator, find the exact value of the sin 2 theta and the cot theta. Okay, so for this kind of the technique, it is very useful, especially when we actually do the mechanics, because most of the time, not most of the time, like a lot of times, they will actually give us the sine or the cos of an angle. So they never really give us just the value of the angle. Okay, so by given we have got the value for the cos theta, okay, we should be able to find out what are the values for the sine and the tangent. So this can be easily done by drawing a small triangle. That might be easier. So in this case, we have got cos theta is equal to 3/4. So cos theta equals to 3/4 is so 3 would be the adjacent side, and then the 4 would be the hypotenuse side. So this will give us the opposite side is √7. Okay, so for this one, okay, we are supposed to find what are the values for the sin 2 theta and the cot theta. So from there, it is not difficult to do, because sin 2 theta, we can always write that in terms of sin and the cos theta. So based on the triangle, okay, we can get the values, and hence we can actually get the values for the sin 2 theta. Cotangent theta is easy as well. So knowing that the cot theta is just 1/tangent. Okay, so we can also easily get the value for the tangent theta from the triangle that we have actually drawn. So that will be very straightforward, okay, for this question. Alright, so if you look at the next one, okay, so I guess we'll actually keep this question to the last, because this one, it has a bit more working on it. Okay, so we'll keep this question to last. Next question is to prove that we have got this, okay, bunch of sine square minus 3/4 is equal to 1/4 times √3 times the sine 2 theta. So for this one, okay, we just have to first, okay, know that, okay, sine squared of theta plus 1/3 pi is just sine of theta plus 1/3 pi, the whole thing squared. So what is actually our sine theta plus 1/3 pi is, we can actually use the compound angle formula, okay, which we have sine A cos B plus cos A sine B. So just use the compound angle formula from there, and just have to square the whole thing. So before we actually square the whole thing, it will be easier if you actually evaluate the values for the cos 1/3 pi and sine 1/3 pi first. That will be easier. And just give both values, okay, the exact value. So cos 1/3 pi will be half, and sine 1/3 pi would be √3/2. So just give the exact value for that, because we are going to use it later on. So square this, okay, so remember we still have to square this, okay, then we will actually get a nice expression for this one. Okay, we have got this nice expression after we square that, and the rest, okay, is just, we can just keep it, especially for the negative 3/4, we'll just keep it. And now, because what we want to prove is we want to prove something, that is, we have got sine 2 theta. So before we can actually do that, okay, it's about from here, okay, from this step we have to tidy up until we get this one. Okay, so for okay, so what happened to this term is that we actually have this one. So √3/2 sine theta cos theta. So for this one, because we know that like sine theta cos theta is something related to the sine 2 theta, so we need this sine 2 theta term, okay, in the proving. So just rewrite this, okay, because we know that for sine theta cos theta, it is equal to half of sine 2 theta. Okay, so from there, okay, by using the double angle formula, this is what we have, okay, from the sine theta cos theta, to make it into something which is in terms of the sine 2 theta. And for the previous part, we have got nice result where our sine theta and cos theta, they have squared and they are added together. So this gives us only a 1 from there. So with that, our 3 over 4 can cancel off nicely, okay, which will actually end up with this identity. Okay, so that would be for the first part. Okay, second part, so it says, okay, hence solve the equation, okay, given by this form. So we actually see that for this equation, right, it is actually quite similar to what we have, okay, in the first part. So we just have to try to express what we have in the second part to get something which is similar to the first part. Then we apply, okay, the identity from the first part. So what do I mean by that one is we have first, okay, to divide the whole equation by 2, okay, and then from there we still lack of a constant which is negative 3 over 4, okay, in our left hand side. So what we do is we just minus 3 over 4 from both sides. Okay, so until here, the left hand side is already something that we can apply the identity that we have already proven. So from there, just use the identity proven, okay, where we have this for the left hand side. And from there, okay, we actually end up with something nice to solve, which we actually get, in that case, the sine 2 theta is negative 1 over root 3. So again, this one is to solve for 2 theta. Okay, so given that we have got the theta is in between pi and negative pi, we need to adjust this range to become 2 theta. So for this 2 theta, it would be in between negative 2 pi to 2 pi. So for this, okay, the best way to work with it is we need to give the basic angle first, then we will actually see, okay, what can we do from the basic angle. So okay, with that, okay, what we have from there is we have got the basic angle, which we have the 0.615. This is our basic angle, but in this case the sine is a negative value, so we will actually have the angles in the third and the fourth quadrant. So the first two values here gives the value in the third and the fourth quadrant. Okay, and then the next thing is, okay, these two values is as if we solve the 2 theta, okay, from 0 to 360. We just solve it like that first, and we will see later whether do we need to add 2 pi to those values or minus 2 pi to those values in order for us to get the complete set of the values, okay, inside the required range. Okay, so from there, okay, for these two values, okay, we can, okay, minus 2 pi to these two values from there, because we want to cover the part where we have for the negative values, okay, for the 2 theta, because we still have like from negative 2 pi to 0 to cover. So other than that, adding 2 pi to the first two values here is out of the range already. Okay, so from there we will only minus a 2 pi from the two values to cover up for the negative values. Okay, so from there just have to tidy up, okay, and just give the full sets for the values for the theta in that case. Okay, so remember to give our answer in 3SF lah, because this is the value in the radian. Okay, so that would be for question 8. Next. Okay, so for this question, it is another thing that is worth to take note, because for this value, okay, we have got tangent theta plus 10. So we are supposed to solve for theta plus 10, and we have to whenever we start solving, we have to adjust the range first. So for this range, we have got the theta plus 10 is from 10 to 370. Okay, so this is something that we have to take note of. And when we actually try to solve for this, okay, the basic angle that we get here is 5.71. Okay, so first thing first, 5.71 is not in the range. Okay, so although for tangent equals to a positive value, we have quadrant 1 and quadrant 3, but for this one, 5.71 is not in our range, so we cannot consider that. So what we can do is we'll actually have to move on. So for the first quadrant value, we are not going to take. Okay, so instead we'll actually take the third quadrant value. So the third quadrant value is we actually add the 180 to the basic angle. Okay, so for this first value is already something that we have solved, okay, in from 0 to 360. So we will actually see whether we need to add 360 or not. So in this case, yes, we have to add the 360 because supposingly, if the 5.71 is in the range, okay, it will be part of our solution, but it is now not in the range. So we will have to try out by adding 360 to it and see whether it is in the range or not. So in that case, it is in the range, so we have to include it. So it is not useful if we actually add 360 because it will be out of the range, so it will be not useful. So in that case, we will only have two values, okay, which we actually get these two values. And once we minus 10 from those values, so we can actually ensure that the values, okay, for the theta is in 0 to 360. Okay, so we can actually make sure that, okay, our values is actually in the range. Okay, so that's for this question. So although it's 4 marks, but it's quite easy for us to miss some of the values from that. Okay, right. For this one, okay, is to look at the sketching, okay, for the y is equals to secant theta. So to sketch this secant theta, the idea is very similar to what we have explained earlier on. So this is basically to base on the curve that we have for the cos theta, and we just use a 1 over cos theta. Okay, so with that, we can actually sketch this graph for the secant theta, okay, by using the idea that we have learned before. Okay, so for part B is to solve for the secant theta equals to cosecant theta. So this can be easily done by changing the secant theta and cosecant theta as 1 over cos and 1 over sine. So we get sine equals to cos, which we can actually move the cos to divide. Okay, so we get tangent is equals to 1. So in this case, the tangent is pi over 4 and 5 pi over 4. Okay, which is not difficult to solve for this one. Okay, so now we can actually go back to that question, which is a little bit tricky. Okay, first one, we have got sine 2 theta plus a half pi is equals to cos 2 theta. Okay, so for this one is by using the compound angle formula. Okay, shouldn't be a difficult thing to do. Okay, so we can actually get the proving quite easily. And for second part, okay, hence solve the equation sine 3 theta equals to cos 2 theta. For this one, okay, we will have to use the identity that we have actually got earlier on. So because the only similar thing that we have here is a cos 2 theta, so we are going to substitute this into the right hand side here. Okay, so this is where what we get. Okay, so a very common mistake that we might make is that, okay, because we have got both sides, we can actually just cancel them off. So when we actually cancel them off, what we get is we have 3 theta is equals to 2 theta plus a half theta, half pi. So in this case, the theta is just a half pi. Okay, which in this case it is not correct. Okay, consider the case where, okay, let's say we have a case which is like sine 3 theta is equals to sine 90. So in this case, we are not going to just cancel off the sine and we get the theta is a 30, which is not correct. Because what we have is for sine 90, it's actually a 1. So the 3 theta actually have more values to actually solve. Okay, so we cannot just cancel off the sign and we solve the value. Okay, so what we do here is we will actually try to fix the 3 theta. So let's say we are trying to solve the 3 theta, and we have got a sine of this angle, so 2 theta plus a half pi. So because, okay, what we have in the example earlier on is that, okay, let's say this is sine 90, right? So because like sine 90 is equals to a 1. Okay, so let's look at this. So sine 90 is equals to a 1. So in this case, the basic angle that we have here is in this case is a 90. Okay, so we'll actually use this angle to actually find more angle because this is just one of the basic angle. So our solution for the 3 theta must be something else that actually have more. Okay, so we can always take this as the basic angle. We should actually do it here. Okay, so that value 2 theta plus half pi is just one of our basic angle. Okay, and from there what we usually do to the basic angle is that because we have got the value for the sine, so for this case, okay, the 3 theta, okay, because we say the theta is from 0 to 2 pi, so in this case for the 3 theta is in between 0 to 6 pi. Okay, so it means we actually have to add on a lot, okay, of the angles from there. So what happens is that, okay, we have got this is our alpha, the basic angle, which is 2 theta plus half pi. So that is our basic angle. So to get the next angle, okay, that will be in the second quadrant already. So if it is in the second quadrant, we use a pi to minus the basic angle, which will actually get it here. Okay, so with that, okay, what happens is that we have got these two angles already, which is sort of, okay, we do not know it yet, but this is sort of in the usual 0 to 360 or 0 to 2 pi. This is usually what we do, like usual. So if we want to extend the values, because we have the 3 pi is from 0 to 6 pi, so for us to extend the value, we just have to keep on adding 2 pi to the original values here. So these two values are in 0 to 2 pi ma. Okay, it is something or sort of something like that, and we have to extend because we have got again 3 theta is up until 6 pi, so we just have to keep on adding. So we just keep on adding on. So don't worry, we just keep on adding because we want to get as many values that we want, and later on, okay, what we have to do is we just have to cancel off. Okay, so in that case, what we actually have to do is we just add all the values from there. Okay, and what we have is if you can see here this. Okay, so for this part, okay, the angles that we have for the left hand side here, it is basically out of the range already, because if you are looking at the values for the 3 theta, it's up until 6 pi only. But for this one, the 2 theta is already up until 4 pi. Okay, so if you actually add 2 pi or more than that, okay, that will be outside the range already, which is more than 6 pi already. Okay, so for the rest of these values, so these are the values that we will actually consider. Okay, so for this one we will have got 1, 2 and another 4 here, so we actually have like 6 values here. So of course we can actually add more, we can actually add until 10 pi, but I think this one will be out of the range already. Okay, so okay, for the next part is of course list down all the values of. Okay, so carry out all the calculations for all this, okay, and list down all the values here. Okay, and just have to rearrange or solve the theta from there, because we have got like 2 theta and also the negative 2 thetas. So for each one, okay, we find the value of the theta, and for these 6 values we will actually have a repeated value, which is half pi, so we just have to discard that value because they are just the same value. So in that case we will actually have 5 values from there. Okay, so if you actually try to add the 10 pi, add another 10 pi, so you have another value here, right? So this value that we get, if we actually calculate the value for the theta, it will actually be out of the range already, so we are not going to consider that. Okay, and interestingly, if we actually look at the values of the theta that we get here, it actually follows a certain pattern. So the values that we have here, it will actually follow the pattern where we have, which is like k over 10 pi. In this case, the k is we add 4. Okay, the first value is a 1, and then we try to add 4 and we get the rest of the values. So the next value for the k is 21. So 21 over 10 pi is already over 2 pi for the theta, so we are not going to take it. So these are the 5 values that we have for this one. Okay, so in this case for this question, right, so Brian actually asked whether this alpha that we have is greater than 90 degrees. So in this case, yes, because we have got the theta is from 0 to 360. So definitely this one is something which is greater than 90 already. So for this one, we can still proceed with the calculation is because even though when we have the alpha here, the basic angle is greater than 90 already, we still can, okay, let's say for this alpha is equals to 100. Okay, let's say, we still can just use at the 360 and so on to actually get the rest of the value. So it doesn't matter whether the basic angle here that we have is more than something more than 90 already. Okay, so this is to for this case, for it to be easier and not to confuse ourselves, we just treat the alpha as something which is acute. Then we just have to do the rest of the things from there. Okay, so with this we can actually get this set of the values, which we have the theta is k over 10 pi, where our k is from 1 to 17. Okay, so this is how we actually solve for this question. Okay, so you can later you can actually have a look at it and you try to understand what happened behind that, but just try not to confuse yourself. Just treat the alpha as any angle that we usually use in solving, and then we just have to try to work from there. Okay, so that is it for the this question and the questions that we want to discuss for today. Okay, so if you have a question, you can actually ask me later lah. Okay, thank you. I'll end the video here.